Okay, now we're going to begin to develop an algorithm for multiplying integers. So we don't want to bypass the rectangular form we just saw because that really tells us how we're finding the area. If you go directly to the algorithm, that's just telling you how to do it and not really why we're doing it. So, but I do admit that that grid process was a little tedious. But notice, since we were using base blocks, we were basically breaking it down into place value because that's what base blocks represent. So we're going to scale this down even a little bit more. Here's the same multiplication problem, 14 times 23. But now we're going to break it down by place value. So since this is 23, we're going to say that this is 20. Let me write this in a different color. This length is 20 and this length is 3. And since this is 14, we're going to say that this length here is 10 and this one here is 4. And notice this is actually partitioning it just like the base blocks. This is where the flats are, this is where the rods are, and this is where the units are. So now we're going to find the area of the 4 smaller rectangles. So there's this one, this one, this one, and this one, in which the big rectangle is partitioned, and label them in the figure. So this rectangle, let's get a highlighter. This is 20 by 10. So notice we have to look to the corresponding sides. And if you multiply 20 by 10, I'm just going to shade it in a little bit. Notice this would be 2 flats, 2 rods, 1 rod, which would give us 2 flats filled this in. So this is 20 times 10 is 200. Now let's look at this rectangle. Well, this length is 4, and this length is the same as this labeled length up here. Notice that they're parallel and they're the same distance. So if we had 4 times 20, this would give us 80. So again, think of it as we had 2 columns of 4 rods here. So that would give us a total of 8 rods filled in here. A rod is 10, so this is 80. Now let's look at this. We have 3 on this side, and this corresponds to this. So this is also 10. So it's 3 by 10. Well, 3 times 10, or 3 tens, or 3 rods, is 30. And then finally, we have 1 piece left, and these numbers should all look familiar. This was 3, this was 4 from over here. So this piece right here is 12. Okay, so we found all of these different amounts. And now we're going to represent this, so we can add them up, 200 in any order we want, 80, 30, 12, combining them all, 8, 9, 10, 11, 12, we get 322. Okay, but now we're going to represent this using the extended algorithm. That's just going to show us how all these pieces fit into the algorithm that you probably learned in school. Okay. So we're going to write 14 times 23 and put a line under it, and this line means equals. So now let's see how all of the pieces correspond. So we're going to write these 4 sums and get them from these numbers. So you may remember that when you learn to do the standard algorithm, which is going to be a little bit briefer, you start here, you multiply these. 3 times 4 is 12, and you may have said 2, carry the 1. We're not going to carry the 1. We're just going to say this is 3 ones and 4 ones, so this gives us 12 ones. And notice that's coming from this 3 and this 4. There's our 12 ones. Now we're going to say, well, I have 3 ones times 10. So 3 times 10 is 30. Okay, and that's representing this piece, 3 times 10. When you move on to the next place, remember this 2 really represents 20, and this 4 is 1, so 20 times 4 is 80. And we're getting that from 20 times 4. And then finally, 2 times 1, you'd say that's 2, but you put it in the place value here because It's really 10 times 20, which is 200. And then you add up the results. I'm out of room a little bit, but we did the same idea here. So we have 322 when we add them together. So we're calling this the extended algorithm because we're writing all 4 pieces here, but notice how we didn't have to draw this rectangle. We just did 3 times 4 is 12, 3 times 10 is 30, 20, or 3 times 10 is 30, 20 times 4 is 80, and 20 times 10 is 200, and then we sum them up. So now notice this could be a little cumbersome, and this was only 2-digit numbers, so our standard algorithm is going to break this down for us a little more, or condense this a little more. So let's look at that on the next slide. So I've copied the extended algorithm right up here, so we have this handy, and now let's use our standard algorithm and see how it connects to this extended algorithm. So we have 14 times 23. Now, you start in the ones place. 3 times 4 is 12, and that's 12 ones, which is 2 ones and 1 rod. So we carry the 1 rod over to this tens place, because remember, when we're multiplying these, multiplying 3 times 10, which is 30, and then we can add one more 10. So 3 times 1 is 3, plus 1 is 4. So we condense that into one line, but notice this corresponds to adding the 12 and the 30. It's the 12 plus the 30. Here we did the 2 ones and carried the 110 to the next spot. Okay. Now, you may remember that the next thing you do is when you move on to the next number, you put a placeholder of 0. Okay? And basically the reason for that is now we're going to say 2 times 4 is 8, but we're really multiplying 20 times 4. So this 0 placeholder is actually giving us the correct place value. So we have 2 times 4 is 8, and then we have 2 times 1 is 2. So now let's see how that corresponds. So we have 280, and we got that by adding the 80 and the 200 together, but we did it in just one step. So the 2 times 4 was 80, and since we put the 8 there, it's in the tens place. The 2 times 1 is 200. Since we put it to the left of the tens place, this 2 represents a 2 in the hundreds place. Okay, so our standard algorithm is very, very efficient. Now we'd add these up. 2 plus 0 is 2. 4 plus 8 is 12, so 2 carry the 1 gives us 322. Okay, so it's important for you to see where this is derived from, because lots of times you learn this and you just start doing it and you don't really know how the pieces are fitting together with place value and with multiplication. So keep these ideas in mind when you're working out the problems. So now it says use your results from above and your knowledge of integer multiplication to find the following. So you may look at this and say, oh no, there's 4 new problems, I have to do that 4 times. But you actually don't, because notice all of these have 14 times 23. And you wrote and we learned that when you're multiplying positive numbers, you get a positive. If you multiply 2 negatives, the answer is positive. And if the signs are different in either order, your answer is negative. So if you were given any of these problems independently, your first step would be to find 14 times 23, their absolute values, which you'd find is 322. And then you determine the sign based on your knowledge of integers, right here, of integer multiplication. So positive times positive is positive 322. Negative times a positive, well, that would be negative, so this would be negative 322. Positive times negative is also negative, so this is negative 322. And a negative times a negative is positive, so this is positive 322.